Let's take a look at page 386, example number 3, and I'll go over example 3a. So what do we notice here is that we have three fractions that we need to combine. This middle one is over 1. So I'm going to rewrite this so that it is 7x plus 3. I like to put my brackets so that I know that I'm distributing anything over the binomial. 3x, and then same thing here. It's really important for the ones especially which have negatives, because even if you are distributing just a negative or a -1, it makes a difference to have the bracket around. So over here, my common denominator here will be 8, meaning the first one needs to be multiplied by a 4, because the 2 needs to be multiplied by a 4 to become an 8. This needs to be multiplied by 8, so will this. This is fine, so this only needs to be multiplied by 1. I like to put even a 1 there, so that way I know what everything got multiplied with. So the numerator would be 4 times 7x plus 3 plus an 8 times 3x, and then -1 times x minus 3. Now we're going to open up our bracket and we will distribute the term outside. So this is 28x plus 12 plus 24x, and this negative gets distributed to make it -x plus 3. So at this point, we're going to combine our like terms. So all the x terms will get combined. So that's a 1x here, remember? So 28 plus 24 minus 1 will give me 51x. And then these whole numbers will combine to give me 15 all over 8. So remember, once again, if something needs to be reduced, it needs to be reduced from all the terms. And there is nothing common between 51, 15 to divide out to produce this 8. So this is our final answer. You don't need to put those brackets, but I just have a force of habit to put those in there. So B is the same. Please make sure you watch your modal to look at the examples at that one. If we look at examples in this one over here, let's try doing one of these examples here. Let's do B. Again, I'm just rewriting it so I can put my brackets where I need to, so that I don't make any mistakes when I'm opening up my brackets. So this already has a common denominator, which is a 2a. I don't really need to multiply anything with. You could just say I'm multiplying each of them with a 1 because they already are what they are. So 1 times 5a plus 3. The only benefit of writing it like this extra step, is in case if there's a negative here, then it reminds us to distribute it. So this is a good step to write, just so that we can have like a visual reminder to make sure that we distribute our signs in, especially if it is a question with a negative in between here. In this particular one, it wouldn't have made any difference. And then when we combine our like terms, it becomes a 6a minus 3 over 2a. And I have a non-permissible value where my a cannot equal to 0. And then I'm going to try reducing it. Now, in order to reduce, remember, it should be something that reduces all terms, or something that you can at least factor out from the first one to reduce it. So because this 2 cannot reduce every single number, you will not reduce the 6 and 2 or the a. Okay? So the only scenario where this would have been possible is, for example, if you had something like this. Then you can see that every single term here can be reduced by a 2. So one way of looking at it is like reducing every single by 2. And your final answer is 3a minus 2 over a. Or another way to also approach this is to think of factoring out a common denominator, a common factor. So if you said, oh, I can take a 2 out from the top, and then I can also then reduce that 2 with the denominator. So those are the only times you could reduce it. But unfortunately, our question, there is nothing common. So this is the final answer. Okay. Let's take a look at part D as well. Here again, the common denominator is going to be this expression binomial x plus 3. And once again, because they both have the same, they only need to be multiplied by 1. So if I multiply this 1 in, you don't need to write that in, but you just need to make sure you multiply it in. The first bracket, nothing changes. But in the second one, it becomes negative 2x minus 4. And then when we combine it, it ends up becoming 2x plus 6 and x plus 3. And then x cannot equal to negative 3. Now, before I reduce it now, so here you can see that I can take a 2 out from the top. And this also is x plus 3. Now these both can get reduced. So my final answer is just a 2 over 1 or just a 2. Okay. So the only time you can reduce things is when everything is in a good factored form. Okay. So this is my final answer for part D.